Compare the two logarithms with different bases and arguments, where x is greater than 1. Some students chose specific values of x, and then calculate the logarithms using calculators. Note that calculators are not allowed for comparing the two logarithms. To compare two algebraic expressions, usually we can evaluate their difference or their ratio. To see whether the difference is greater than 0 or is less than 0. Or to see whether the ratio is greater than 1 or is less than 1. We can't compare the logarithms if their bases and arguments both are different. We need to convert them into logarithms with the same bases or the same arguments. We can use the change of base formula to convert them into logarithms with the same bases. Log to base b of a equals log to base k of a over log to base k of b. We choose k equals e by applying this formula. Log to base x of x plus 1 can be written as ln of x plus 1 over ln of x. And log to base x plus 1 of x plus 2 can be written as ln of x plus 2 over ln of x plus 1. We will evaluate the ratio of the two logarithms. So log to base x of x plus 1 over log to base x plus 1 of x plus 2 equals ln of x plus 1 over ln of x over ln of x plus 2 over ln of x plus 1, which is equal to ln of x plus 1 over ln of x times ln of x plus 1 over ln of x plus 2. So log to base x of x plus 1 over log to base x plus 1 of x plus 2 equals ln of x plus 1 all squared over ln of x times ln of x plus 2. Now we need to evaluate whether the numerator is greater than the denominator or vice versa. We know that the arithmetic mean is always greater than or equal to the geometric mean. That is, x1 plus x2 plus so on plus xn over n is greater than or equal to the nth root of x1 times x2 times so on times xn, where x1, x2, and so on, xn, are non-negative numbers. Note that the equality holds, if and only if, x1, equals x2, equals so on, equals xn. We let x1 equal ln of x, and x2 equal ln of x plus 2. Note that we are given that x is greater than 1. So both ln of x, and ln of x plus 2, are greater than 0. So they satisfy the condition of non-negative numbers of MGM. By applying MGM, we have ln of x plus ln of x plus 2 is greater than 2 times root of ln of x times ln of x plus 2. Note that the equality does not hold, as ln of x does not equal ln of x plus 2. The left side of the inequality is the sum of two logarithms. The product rule for logarithms states that log to base b of x plus log to base b of y equals log to base b of x times y. So the left side of the inequality can be written as ln of x times x plus 2. Because x plus 1 all squared is greater than x times x plus 2, and ln of x is monotonically increasing. So ln of x plus 1 all squared is greater than ln of x times x plus 2. From inequalities 2 and 3, we have ln of x plus 1 all squared is greater than 2 times root of ln of x times ln of x plus 2. We know that the power rule for logarithms, log to base b of x to the power of n, equals n times log to base b of x. By applying this, the left side of the inequality can be written as 2 times ln of x plus 1. Now square both sides of the inequality, we have 4 times ln of x plus 1 all squared is greater than 4 times ln of x times ln of x plus 2. 4 on the left side of the inequality and that on the right side of inequality cancel. So we have ln of x plus 1 all squared is greater than ln of x times ln of x plus 2. From 1 and 4, we know log to base x of x plus 1 over log to base x plus 1 of x plus 2 is greater than 1. Therefore, log to base x of x plus 1 is greater than log to base x plus 1 of x plus 2.